We will continue with section 7E, which is counting and probability, and we'll do pages 7, 8, and 9 in this video. Now, here's an interesting problem. Problem 12. Let's look at it. Suppose you have a party with 20 people, and you are one of the 20 people. So it's you and 19 guests. So what is the probability that at least one of your guests will have the same birthday as yours? So your birthday is one day out of the 365 days in a year. So probability that a person has your birthday, a specific day in the year, one day in the year, so that would be 1 over 365. The next one is, what is the probability that a person does not have your birthday? So this is the opposite event. So it's 1 minus 1 over 365. If you simplify it and write it as a fraction, it's 364 over 365. So what is the probability that at least one of the 19 people has your birthday? So remember, the term at least suggests using the at least rule because it's much easier than listing different possibilities for 20 people in the party. So probability that at least one of the 19 people has your birthday is equal to 1 minus the probability of the opposite event, which is none of the 19 people have the same birthday as yours. So that is equal to 1 minus probability that the first guest does not have the same birthday, the second guest does not have the same birthday, the 19th guest does not have the same birthday. So that is equal to 1 minus probability that the first does not have the birthday and the second does not have the birthday and the 19th does not have the birthday. So that is equal to 1 minus 364 over 365, 364 over 365, all multiplied together. And there are 19 people, so it's 1 minus 364 over 365 to the 19th power, which is equal to about 5.3%. So there's a small chance that at least one of the 19 other guests will have the same birthday as yours. Now next, we still have the same 19 guests. What is the probability that some pair of guests shares the same birthday? That is the same as saying at least one pair shares the same birthday. Now, the minute we use at least, that should remind us of the at least rule, that is equal to 1 minus the probability that the opposite happens, opposite of at least one pair shares the same birthday. What does that really mean? What it means is that no two people share the birthday, which means all 19 people have different birthdays than each other and, of course, yours. So 1 minus probability of each one of these having a different birthday is 364 out of 365, 363 out of 365. We need to start excluding the people who come before. So our first guest cannot have the same birthday as yours, so he has a choice of 364 over 365 birthdays. So that's the probability that his birthday will not be on the same day as yours. Now, the second guest cannot have the same birthday as the previous guest and the one before, so it would be equal to just 363 out of 365, and keep going on and on. So that would be that simplifies to this expression, and when you use your calculator, you get 0.4114. So this would mean that about is a 41.14% chance that uh, some pair of guests share the same birthday, and that's a pretty good chance. If you invite 19 people, then the probability that some pair of guests would share the same birthday is 41.14%. So in this problem, 13, we need to find the probability of choosing a specific selection of 5 numbers, and this selection is made from numbers starting from 1 through 42. So there are 42 numbers to choose from. We need to find the probability. Probability is a ratio. It is something over something. So what is the probability of choosing the winning selection of numbers? How many winning selections do we have? We have just one specific selection of 5 numbers, and that would be the winner. So there's only one out of a total number of selections of 5 numbers from 42 numbers. How many ways can we select 5 numbers from 42? Here, remember that the order is not important. So we have 42 numbers, and we need to choose 5 numbers from it. So the probability of choosing the winning selection is 1 out of the total of 42 choose 5 numbers. And when you enter these numbers into the calculator, 42 choose 5 is 1 over 850,668, and that number is really, really small. So winning a lottery is something like choosing one such selection from a total of a large number of selections. So the probability of winning that lottery is 1.1755 times 10 to the sixth power. Just to give you an idea, it is something like 0.00000176 if you had to just round it off at some point. So that is our chance of winning a lottery. Now, in the next problem, we need to find the probability of guessing the top 3 winners in order. That's the important part here. Not just the top 3 winners, in which case it would be selecting 3 people. Here, if we need to select them in some sort of order, then we are not talking about a selection, we're talking about an arrangement or a permutation. So there is just one winning combination along with the order of contestants. So there's one permutation or one arrangement that is a winner out of a total number of arrangements of 10p3. From 10 people, we arrange 3 at a time. So that is 10p3. It's not just selecting 3 people, it is selecting and then arranging them in different ways. So that would be a permutation. That's why we go 10p3. So the total number of arrangements of 10 people taking 3 at a time is 10p3. So that would be 1 over 720. That is your chance of guessing the top 3 winners in order. So the order here tells us that it is not just a selection, but it's a permutation. In this problem, we need to find the probability of selecting 3 Ohio students from a group of 16. So there are 16 people, 7 of whom are from Ohio, and the rest of them, that is 9, are from outside of Ohio. So what is the probability of choosing? And the minute we need to select or choose what we're talking about is a combination. So, how many different selections of three students can we make from a total of seven Ohio students? So, the numerator is that specific selection. So, there are seven C3 ways of selecting three Ohio students from a total of seven Ohio students. So, that is with that particular restriction. Now, probability is a ratio, so the numerator is the specific selection divided by the total number of unrestricted selections. So, from a total of 16, how many different selections? So, from 16, select 3. So, the total number of selections is 16C3, and when we use our calculator, we get 35 divided by 560. So 560 is 16C3. So number of ways of choosing three Ohio students is the number of ways of selecting three Ohio students from seven. So that's the specific selection divided by the total number of ways in which we can generally select three students from a total of 16 students. And that would be 35 over 560. Now, when we read this question, it almost seems like we need to do a lot of complicated calculations. Of course, that can be done to get the exact same answer. But let's read the question. What is the probability of being in the first half of the program when you're one of the 10 performers whose order of performance is randomly selected? So there are 10 performers, and we can arrange them in different ways. But if we divide the total number of arrangements into two, the first half of the program and the second half of the program. So the when you are part of this program, you're either in the first half or in the second half of the program. So intuitively, the probability of being in the first half of the program is 1/2. But of course, we can get the same answer by doing uh, the calculations in a very rigorous kind of way.